The discoveries made by New Horizons during its brief encounter with Pluto only scratched the surface of the dwarf planet's mysteries. One particularly fascinating feature revealed was Sputnik Planitia, a vast plain of nitrogen ice so smooth and unblemished that it resembled a cosmic skating rink. But a closer look unveiled something even more remarkable: massive polygonal patterns covering the surface, each several kilometers across. These patterns weren't random. Scientists believe they are convection cells, regions where warm nitrogen ice from below rises, cools at the surface, and then sinks again, creating a slow-moving churn not unlike what happens in Earth's mantle or in a lava lamp. These slow convection currents drive glacial movement in Sputnik Planitia, shaping troughs, pit, and ice flows that pour into the surrounding mountains. In this frigid alien world, even the ice behaves like living matter, shifting and flowing over geological time. Some scientists theorize that Sputnik Planitia may have formed in the aftermath of a massive impact. A comet or asteroid could have struck Pluto, creating a deep basin that was later filled with layers of nitrogen ice. Interestingly, the plain sits almost directly opposite Pluto's largest moon, Charon, which hints at a gravitational relationship between the two. Over time, the impact basin may have moved due to tidal forces and realigned itself in a stable position due to Pluto's interior mass distribution. Even more compelling is the possibility that beneath the surface of Sputnik Planitia lies a subsurface ocean of liquid water, kept from freezing by residual heat from Pluto's formation or radioactive decay. This internal ocean hypothesis makes Pluto even more intriguing, not just as a frozen relic of the solar system, but as a world with the potential for complex chemistry and perhaps even the basic ingredients for life. As New Horizons passed by, it also mapped the atmosphere of Pluto. Once thought to be negligible, Pluto's atmosphere surprised scientists with its layered haze and complex structure. The spacecraft detected a thin layer of nitrogen, methane, and carbon monoxide extending hundreds of kilometers above the surface. These gases scatter sunlight and create a bluish glow around Pluto, especially when viewed in backlight. The haze itself isn't just a beautiful sight. It reveals a rich photochemistry occurring in the upper atmosphere. Sunlight breaks apart molecules like methane, allowing them to recombine into more complex hydrocarbons called tholins. These reddish compounds eventually fall to the surface, giving Pluto its distinct brownish-red color. Remarkably, some of these processes may be similar to those that occurred on early Earth, reinforcing the idea that even the most distant worlds can offer clues about our planet's past. Meanwhile, Charon, Pluto's largest moon, had surprises of its own. Larger than any other moon relative to its parent body, Charon shares a unique gravitational relationship with Pluto. They are tidally locked to each other, always showing the same face, and orbit a common center of mass located outside of Pluto's surface. In effect, they're a binary dwarf planet system. Charon's surface was found to be drastically different from Pluto's. Lacking an atmosphere, it features large canyons and troughs that stretch across its surface, some of them deeper than the Grand Canyon. The northern hemisphere is marked by a dark reddish cap, nicknamed Mordor Macula, likely caused by methane escaping from Pluto and transforming into tholins after settling on Charon. Tectonic features on Charon suggest internal stretching, which could mean the moon once had a subsurface ocean that froze and expanded, cracking the surface. The presence of such geological activity in a place so far from the sun was unexpected, and it reminded scientists that even small, icy worlds could be dynamic and evolving. The data sent back by New Horizons continued to astonish for months after the flyby. Because of the spacecraft's immense speed and the limited communication bandwidth with Earth, it took over a year to transmit all the collected data. But each new image and measurement brought fresh revelations, from the complex layering of Pluto's ice cliffs to possible cryovolcanoes, ice volcanoes that once erupted slushy water, ammonia, or methane. What made all this more impressive was the fact that New Horizons did it all during a flyby. The spacecraft didn't slow down or enter orbit. It had one chance to capture data as it sped past Pluto at over 14 kilometers per second. Every camera angle, every sensor activation had to be pre-programmed with split-second precision. There would be no second chances. Once the Pluto mission was complete, New Horizons wasn't done. NASA extended the mission to explore the Kuiper Belt, sending the spacecraft even farther into uncharted territory. On January 1, 2019, it flew by a small, peanut-shaped object known as Arrokoth, formerly Ultima Thule. This distant world, located over 6.5 billion kilometers from Earth, is one of the most primitive bodies ever observed. Arrokoth offered a glimpse into the solar system's ancient past. Formed from the gentle merger of two smaller objects, its surface was almost entirely unchanged for billions of years. It confirmed the theory that Kuiper Belt objects formed through slow, delicate processes rather than violent collisions. Studying Arrokoth gave scientists invaluable insight into how planets may have begun forming in the early solar system. With each new milestone, New Horizons continued to challenge expectations. It showed us that distant doesn't mean dead. Even tiny worlds at the frozen edge of our solar system are shaped by complex geology, chemistry, and physics. They're places of history, mystery, and potential. And as it continues to cruise through interstellar space, New Horizons reminds us of the boundless curiosity that drives exploration. It is a silent emissary, still beaming data back to Earth, whispering tales of worlds we had once dismissed as insignificant dots. What lies next for New Horizons? What secrets still wait in the deep dark of the Kuiper Belt and beyond? Stay tuned as Infinity Beyond brings you closer to the farthest reaches of the known solar system and what lies just beyond.